Good morning everyone. Myself Prashant Patil. Today we will start new topic or new chapter which is linked list. Before starting new point or new chapter, just we recall the previous lecture points. In previous lecture we discussed some points which are radix sort. Also we discussed step by step procedure of radix sort. Also we studied different examples of radix sort. Today we will start new chapter. The name of the chapter is linked list. In linked list we will see some points which are listed here. First we will discuss introduction of linked list or definition of linked list. Also we will discuss linked list terminologies. Then we will discuss basic different operations of linked list. First we will see definition of linked list. Basically, linked list is a data structure that consists of sequence of nodes. See carefully, linked list is a one type of data structure. In this data structure which consists sequence of nodes. Afterwards we will see what is meant by node. Such that each node in list which contains two fields. See carefully, in a single node which contains two fields. One field is data field and other field is address of next node. This sequence of nodes is called as linked list. Like arrays, linked list is a linear data structure. Unlike arrays, linked list elements are not stored at contiguous memory location. Actually, when we store the elements in an array, then we will store all the elements continuous memory location. But in a linked list, elements are not stored at a contiguous memory location or continuous memory location. The elements are linked using the different pointers or number of pointers. Now we will see what is meant by node. Now see in the figure, one node is present. Already we discussed what is meant by node. Basically, node made by two fields. The first field is data field and the second field is link field. In data field, we will store actual value. The values are 0 to 9, a combination of 0 to 9, also the combination of A to Z. In link field, which stores the address of next node. Now see in the figure. In the figure contains three nodes. Node A, node B and node C. These three nodes are connected with each other. Every node has its own address. Node A has 1000 address, node B address is 2000 and node C address is 3000. A linked list containing three data fields. First data field is x1, second one is the x2 and third one is the x3 is represented linked list. Basically, node A stores data x1 and address of next node which is node B. Node B stores the data x2 and address of node C. Node C stores the data x3 and its address field is null. Once again I will discuss this figure. In the figure contains three nodes. The first node is node A, second one node B and the last one is node C. Basically, node A stores at memory location 1000. Node B stores at memory location 2000. Node C basically stores at memory location 3000. First we will see what is meant by node. Node is the combination of data field and address field. See in the figure, in node A, data field is x1 and address field is 2000. Basically x1 is actual element and 2000 is the memory address of next node. Means 2000 is the address of node B. Likewise, in a node B, x2 is a data field or x2 is the element, and next field stores the address of next node. The address of next node, which is node C, and node C address is 3000. That's why 3000 is stored in node B address location. Likewise, in node C, x3 is the element or data field which contains x3, and next field which is linked to the null. Actually, node A, node B and node C, which are connected with each other by using the pointer. This is called as linked list. Now we will see new point, which is linked list terminologies. The first terminology is data. The second one is the next. Third one is the address. Fourth one is the node. Fifth one is the null. And the last one is the empty list. Now we will discuss the first terminology, which is data. Basically, data, it contains the information related to the element. Already we seen that data field which contains the elements. x1 is the element, x2 is the element, for example x3 is the element. Second one is next. Actually, next is the pointer field which stores the address of another field, another node. Already we discussed in the previous slide next field which contains the address of next node. The third one is address. Address field contains address of next node. Basically, next and address both are same. In address field contains the address of next node. Means that node A stores the address of node B. The next one is node. Already we discussed what is meant by node. The type for a pointer to node is called as node pointer. Basically, node which contains two fields. One field is data field and second field is the address of next node, or which is called as linked field. Next one is the null. Basically, null indicate the end of linked list. The next one is the empty list. Nodes are not present in the linked list, then it is called as the empty list. In the previous slide, we discussed three nodes, node A, node B and node C. Means in the figure contains three nodes. So this is not a empty list. If suppose in the figure nodes are not present, then we will see empty list. Now we will see new point, which is basic operations of linked list. The first operation is insertion operation. Second one is deletion, next one is display, and the last one is search. Insertion, first we will see insertion. Insertion means adds an element at the beginning of the list. Means node is added in the linked list at the beginning. Then we will see deletion. Deletes an element at the beginning of the list. Suppose if you want to remove an element from the linked list, then we can perform the operation deletion. The next point is display. Displays the complete list. Suppose if you want to display all the elements in the linked list, then we will perform display operation. The next one is the search. Searches an element using the given key. Suppose if you want to search any element in the list, then we can perform search operation. Now we can see here new point, why linked list. Array can be used to store linear data of similar types, but array have some limitations. The first one is the size of the array is fixed. So we must know the upper limit on the number of elements in the advance. Also, generally the allocated memory is equal to the upper limit irrespective of the uses. The second one is inserting a new element in an array of elements is expensive because the room has to be created for new elements, and to create room existing elements have to be shifted. For example, in a system, if we maintain a stored list of IDs in an array, ID, then array is 1000, 1010, 1050, 2000, 2040. This is an array. The next point, which is advantages over the array. The first advantage is dynamic size. Basically, dynamic size means size is not fixed. Means that if you want to insert new element in the linked list, then we can easily insert the new element by using the different inbuilt methods or different inbuilt functions. For example, malloc, calloc, etc. The second one is ease of insertion and deletion. Suppose if you want to insert new element in the linked list, then we can easily insert in the linked list. Suppose if you want to insert at beginning, then we can easily insert at beginning. Suppose if you want to insert at end, then we can easily insert the end. Suppose if you want to insert in between the list, then we can easily insert the new element into the middle of the list. Likewise, we can delete the first node of the list, we can delete last node of the list, then we can delete in the middle list of the node. Now we will see drawbacks. The first drawback is that random access is not allowed. We have to access elements sequentially, starting from the first node. We cannot do binary search with linked list effectively with its default implementation. The second one is extra memory space for pointer is required. As you already seen that in the node contains two fields. The first field is data field and the second field is address of next node. Means that the second field is an extra field to store the address of next node. And the last point is that not cache friendly. Since array elements are contiguous locations, there is locality of reference which is not there in the case of linked list. Thank you.